in this example, we're going to compute the sample statistic values ourselves. So far in the problems, the chapter problem gave us the values of sample mean and sample standard deviation, etc. Now we will calculate it from the sample raw data itself. So here problem states that the given data represents a random sample of car manufactured in 5 countries. So the data is given here, and we've already seen this data previously where we did a confidence interval for proportion of cars with 6 cylinders. So it's the same data. Okay, suppose that we are interested in the average miles per gallon. Yeah. Now, does the given data support the claim that the miles per gallon is less than 25 mpg for these 5 countries? Okay, here X is miles per gallon rating, okay, for the automobiles manufactured in the 5 countries. Mu is the mean of that. Sigma is the standard deviation of that. Okay. Now we want to test and see whether the MPG rating for the automobiles manufactured by these countries is less than 25 miles. So 25 goes here, and if you want to be able to, at the end of the day, we want an opportunity to be able to say that it is less than 25, that has to go in the alternative. So this must be less than 25, which makes the null hypothesis greater than or equal to 25, and let's say we want to test it at 5%. Okay. Now n is, let's do something here. Let's go ahead and give the MPG column a name. So here you highlight the entire column including the top label, and then you go and say create from selection and use the top row as the name for the rest of the column. So now MPG is named, so now we can go count MPG will give us the sample size. Average MPG will give you X bar. stdev.s MPG will give you the standard deviation. Okay, now S over square root of n, so that is S over square root of n gives us the standard error. Now sigma is unknown, we are now relying on the sample standard deviation, so it is t statistic, so that's X bar minus the mean divided by the standard error, and you get minus 0.22. So this is pointing to the left side, the lower side. So degrees of freedom is n minus 1. Okay, in the critical value approach, the t table. Okay, so we can now do t dot inv, and this is a one tail, so we should use t dot inv and not t dot inv dot 2t. And now this is the left side, so the left side tail area, see t dot inv probability is always the tail area. So the tail area, what we want is alpha itself. It's not 1 minus alpha over 2, because 1 minus alpha over 2 would be on the tail area on the right side, the cumulative area for the right side. This is the cumulative probability we want. So cumulative probability for the left side is just the tail area, and the degrees of freedom is that. So that gives you minus 1.69 as the critical value. So if our t falls outside that value, then we will reject, but it is not. Minus 0.23 is the t-stat value, and therefore we cannot reject the null hypothesis. So now t-stat is greater than that. Okay, if it is even less than the negative value, then we'll reject, but it is not, so we do not reject the null hypothesis. P-value approach is t dot dist. So now this is not the right side tail, it is not two tail, it is just one tail on the left side. So we use T dot dist, the cumulative probability. So you give the T stat value, and then the degrees of freedom, and now you have to say cumulative probability. Otherwise, it will give you the height of the probability curve. So 41, let's make that into a percentage. So 41%, if you reject the null hypothesis, then the probability that you're making a mistake is 41%. That's very, very high. And with that high probability for error, of type 1 error, you don't want to go out on the limb. So you just stay mute. So since p-value is greater than 5%, do not reject the null hypothesis. And now we again give interpretation, which is a two-part interpretation. Okay, so we do not have sufficient sample evidence to conclude that the average MPG of these cars manufactured in the 5 countries is less than 25. So in this case, the p-value interpretation, we are not rejecting the null hypothesis, which means we are not going to be committing the type 1 error. So since we are not rejecting the null hypothesis, then the only chance of an error is type 2 error. We are not going to be committing type 1 error. Okay. Therefore, the way to interpret this 41.1% is to state that we are not rejecting the null hypothesis because the p-value is so high, but if we rejected, if we concluded that it was less than 25, then the probability that we are wrong would be so high. That's the reason why we are not rejecting, because if we did reject, if we did conclude that it was less than 25, our probability of type 1 error will end up being, the probability that we are wrong is going to be 41.14%. It's pretty too high for us to take that chance.